Okay, so this is our first video for your class, and we're gonna start like we don't have a chapter one, so we're gonna start in chapter two. Section 2.1 will be about and graphing functions and using graphing utilities. So your graphing utilities will be this type of calculator that we're gonna be using when we need to, and at the same time I'm using it, you're going to be trained on how to use it. If this is the first time you will be using those graphing calculators. So let's start with the first example where we ask you to identify we ask you to identify the x and y intercept of the graph below. So this is your graph, right? That's your graph right here. And you need to identify the x and y axis, x and y intercept. So basically, it differs with who's teaching this class or how you consider the intercept. We have two ways that we can consider the intercept. We can see the intercept as the x and y values at which the graph crosses the x and y axis. So the x and y axis are this is the y axis and this is your x. The horizontal axis is your number line. The vertical number line is your y axis, and the horizontal number line is your x axis. And you can see how both of them have numbers on them. Now, if you have a graph that crosses the x-axis as a certain number, the location, like this one here, will constitute as your x value of your x-intercept. This is not the x-intercept, actually. This is the x value of the x-intercept. Now, your intercept, your x-intercept, should be written as an ordered pair. However, on MyMathLab, where you're going to perform your homework, they allow you to post the x-intercept as x value and the y-intercept as the y value. But on your test form or your written any work that you're writing to send me, I'm gonna want you to write your x-intercept and your y-intercept as an ordered pair. An ordered pair means you need to have the x value comes first and then comma 0 for the x-intercept. And then the y-intercept, you do the same thing, but the y value goes to the second place and then the 0 comes at the first place when it's a y-intercept. Please, you need to have to take this precaution when you're writing anything to send to me because I'm going to be looking for that. So please, x-intercept in standard x-intercept in ordered pair should be given in parentheses x value comma 0 and y-intercept in ordered pair, which is required for me in this class, should be written as 0 comma y value. But if I ask you for the x and y value, obviously you can just give me values just like it is. So in this case, as we said, the x-intercept is over here, and then that's x value is 1, x value is 1, and then in ordered pair, it's 1 comma 0. So that's an x value equals 1, and then in ordered pair, it's 1 comma 0. Now let's see if we have any y-intercept. Y-intercept will be the same concept, meaning wherever the x-axis, the graph intersects with the y-axis. And as I'm looking here, there's no intersection with the x and the y-axis, so we have no y-intercept. We have no y-intercept. Let's move on to the next example. In this case, we have more intersections. So we can start identifying the intercepts. Obviously, all of these ones are x-intercepts. And then this one is y-intercept. Now, we know the values, right? The values, again, are not the actual intercept. The values are x or y values at which the graph intersects with the axis. But now, if we are giving the x and the y intercepts, you need to provide it in slope intercept form. You need to provide it in ordered pair form. So if on my open math, like I said, they will allow you to just give the numbers, but on a test, for example, I am requiring you to provide the ordered pair for the intercepts. So x-intercepts for the x values, we're going to have -1, -1, -1, 1, and 2 are the values, and then ordered pair would be 0, comma, no, that would be -1, comma 0 for the x-intercept, 1, comma 0, and 2, comma 0. So I have the 3 x-intercepts given in points in ordered pair form. So in the y-intercept, we have just one, which is 4. Y equals 4, it's found at y equals 4. And then the ordered pair form will be 0, comma 4. 0, comma 4. Okay, so intercepts, like I said, are given in ordered pair format provided, but the values can be the x value where we intersect, well, the graph intersects with the x-axis for the x intercept, and the y value of the y and of the y-intercept would be the value of y at which the graph touches the y-axis. Now, the next step here will be for us to graph an actual function. Now, when you're graphing a function, you can manually find the values, or you can use your graphing calculator. What I'm going to do here, the first 3 values here, I'm going to manually find them. And then for the last 4, I'm going to show you how the calculator, the graphing calculator, helps you find them easier. Well, that doesn't mean on the test you may not be able to show me the steps, but easier means that you can use the calculator to verify your answers. So we're going to try to find the y value for x equals -2, -3, -2, and -1 manually. Well, basically, what am I trying to do? what I'm trying to do here is to try to find the some values of the function at certain values. As you can see, I look for it when x equals some negative numbers, when x equals 0, and when x equals from some positive numbers. Now, the idea of finding this is to make sure that I can see the pattern of the function over some positive values for some negative values and 0, and so I can follow the pattern and sketch the graph of the function. So that's the idea. See the pattern, start sketching using those values, and then follow these pattern to extend the pattern that you see. So we're gonna start with finding y for x equals 3. So if x equals 3, x equals, I'm sorry, negative 3. So what do you see? You should see y equals the formula for y is 2 absolute value of x plus 3. So that's 2 absolute value of negative 3 plus 3, right? Now we need to remember the absolute value of a number is the number if the number is positive, or it's the opposite of the number if it's negative. So if the number is already positive, I don't need the opposite to find the absolute value. But if the number is negative, I need to look for the opposite of that negative number, which will be positive, which is the absolute value of that number. So then I can say that y equals 2 times, what's the opposite of negative 3? Which is, I'm looking for the absolute value of negative 3, which is the opposite of negative 3, which is positive 3 here, plus 3. So that is 2 times 3 is 6, plus 3 equals 9. Now let me find the so that's 9. X equals negative 3. X equals, we have negative 3 already, so let's find negative 2. X equals negative 2, then I'm gonna have y equals, the formula for y is right here, right? 2 absolute value of x plus 3. In this case, x equals negative 2, so that's 2 absolute value of negative 2 plus 3. Again, absolute value of a number is itself if the number is positive, and the absolute value of a number is its opposite if the number is negative. This number is negative, so that means the absolute value is the opposite of negative 2, positive 2 plus 3. So that is 4 plus 3, 7. Then, like I said, I'm looking for the manual the values manually for the first 3, and then we will use the graphing calculator to find the rest. And now x equals negative 1. X equals negative 1. We'll have y equals, again, the formula for y, we know it. It's 2 absolute value of negative 2 absolute value of x plus 3. So that's 2 absolute value of negative 1 plus 3. Absolute value of negative 1 is its opposite. So that's positive 1. So 2 times 1 plus 3 equals 5. So this is 5. Now what we're going to do here is we're going to try to switch to the graphing calculator and show you how to use your graphing calculator to do the same thing here. So let's try to use the graphing calculator to find this. So first thing you do is you turn on your calculator. I'm gonna try to turn it on. Well, I turned it on, it was already here, but Obviously this is not where you would find it if you turn it on. That's you're gonna have a blank screen when you turn on your calculator, and then see this, you're gonna try to type. First thing you do is typing the formula of y into y, but you start it by looking for the actual y equals. Just like you see here, there's a y equals, then there will be a y equals in your calculator. That's how you start whenever you're graphing or you need a table for your function. So y equals, it gives me the list of the y values, y equals y1, y2, but we have only one function, so we're going to type that y equals. So it starts with 2 times. So 2, how do you get your absolute value? Pay attention to this. You get your absolute value by pushing the math button, math, and then you move it over under num. So that's math, but over here it's num. So if you shift it over using the right arrow, it would take you the num function. So the num tab gives you, the first option is add. You can either enter or push 1 for the first option over here. So I get the absolute value. And how do I tap X into it? X is found under this button that has XT theta N, or you can push the alpha, and then anything, the green letters will be activated, so you can type them in. But this is always easier for me to find X, so I push the XT theta N to find X, and then move it over because we have nothing to place inside of the absolute value anymore. So the next thing would be outside, so I move it right 1 step. So it's on the right side of the other side of the absolute value. Then I can see what next in the expression of my y. So it was y equals to absolute value of x plus 3. So we need a plus, the plus sign, and then 3. Now I typed my function into my calculator. Now, how do I get a table? Well, I get a table using table. You see how table here is in blue. So that means to activate this button to be the blue command, I need to push the blue button here. Once I push the blue button here, the second, it activated this button to command table instead of graph. So move it, push it, and then now you see when you push it, this arrow up will be moving. That means that's the second button is activated. So then I can go ahead, click this button. It gives me the table. And in this table, all the values are listed. I can get all that I need. For 0, I don't know if you can see really, but 0 is 3. 0 is 3. 1 is 5. 2 is 7. And 3 is 9, which are the same values that we have here. So I just wanted to show you how to use your graphing calculator to find those values tight. So basically, you can repeat this for any function that you need the values on a table for it. Now let's go back to our screen so we can continue the problem and place the values that we just found in the calculator. Okay, so now let's place the values that we found here. We saw that for x equals 0, we had 3 in the calculator. You remember what we had? We had a 5 for x equals 1. and we had a 2, we had a 7 for x equals 2, and then 9 for x equals 3. But obviously, if you don't have a calculator, you can just keep working manually to find all these values, because the absolute value when the numbers are positive is even easier. And also I have them all on my notes posted. All right, so now we have the table. We can move on to placing those values in the, for each of those, we have an ordered pair, right? This is an ordered pair, -3, 9. Let's put that -3, 9. X equals -3, y equals 9. -3, 9. X equals -2, y equals 7, -2, 7. X equals -1, y equals 5, -1, 5. X equals 0, y equals 3, -, 0, 3, 0, 3. And then x equals 1, y equals 5. X equals 2, y equals 7. And x equals 3, y equals 9. Now we have all the values. We can connect the dots to create that line. And then we know that continues indefinitely. Same thing over here. We connect and then extend to create that. That gives me that other side of this. And you see that in this is an absolute value function, which is the reason why you have a V shape of the graph. So that is the example, and these are the steps to graph, and you need to go through the steps. And by the way, you can also use the graphing calculator to actually view your graph too if you want. So basically the same options that we had, we can just use them to instead of choosing the table for your calculator, on your calculator after you type your function. So to quit this page, you have to use this button, but the quit option is in blue. So any option in blue is commended after, should be followed by the push of the blue second button. So blue, and then I quit this. But if I go back to y equals, I can see my function is still in there. And now that I have my function in there, I can just graph it by pushing the graph button. So graph gives me the graph of the function to verify the graph that I saw in my note. So basically that's how you verify, but I do want both sides of technology and algebra when you're doing your work in this class. So the I don't want you to understand that, oh, okay, I'm gonna pick this option and throw away this option. No, algebra is one thing, technology is another thing, and that's why I teach both of them. I want you to understand both concepts. So now let's go back to the screen here so we can continue the notes. All right, so next example here. Next example will be, obviously they ask you to pick your graph, which is easy because you graph it on your calculator and you graphed it on this. And you can see clearly the graph that matches what you had is B. All right, that was the content for our first lesson 2.1.